Okay, we're starting. Today we start polar. Shh, girls. Thank you. All right, we're starting polar. And the whole point here is you're used to rectangular coordinates. So rectangular coordinates look like this. I'm just going to draw it up here. In this one, suppose I was drawing a point out here. For that point, we would go, okay, there's an x, a delta x, and a delta y, and that coordinate there is an xy coordinate, right? Polar, we do it different. In polar, we use the whole concept of the angles for the unit circle and a radius. So for that same point, do we agree that that I wrote the, hang on a second. I wrote the delta y in the wrong place, just so you can see it. Is this delta y right here? All right, but do you see that this is that radius of the unit circle, or the radius of a circle? Remember, if we did something that was not the unit circle, suppose it was a circle with radius 6. Can we describe that point not only by the x and y coordinate, but can we describe it in terms of an angle and a radius? Is that what we've been doing with trig? With the unit circle, have we been describing points, the square root of 2 over 2, square root of 2 over 2, and the square root of 3 over 2, 1/2? Remember those coordinates? Were those described with an angle and a radius? Right? In the unit circle is a radius 1, and the angle, if the coordinate was square root of 3 over 2, suppose this right here, that point had been square root of 3 over 2, 1/2. What angle is that? No. Yeah, pi over 3. So could we describe that on the unit circle as a radius of 1? That point, we could describe it as a radius of 1 and an angle of pi over 6, right? So could you draw that in? Could you just go, okay, I want this point right here, that's a radius of 1, and the angle is pi over 6. Agreed? Do we all agree that we can draw that point in if you all know that it's the unit circle and it's a radius of 1 and the angle is pi over 6? Can you draw that point in? Yeah, that's what polar is. In polar, we don't do x's and y's, we do radius and angles.
Is radius always 1?
No. So this is a polar graph right here. And what it is see, each one of those bands is a radius. This is a radius of 1, that's a radius of 2, this is a radius of 3. Notice the unit circle angles are labeled on it. Do y'all see that? Look at this. To get this point right here, so in polar, it is going to be the radius, comma the angle, that's going to be in radians. And that point right there, this point right here, is, for that means the radius is 3 and the angle is pi over 4. So let's go through this. So if I'm going to do the radius, do you see that this is 1, this is 2, and that's 3? Do you see how it's on the band for a radius of 3? So if I'm looking at this one right here, do you see that that angle is pi over 4? So it's a radius of 1, 2, 3, and the angle is pi over 4. Can you label that point the same way you could have labeled it using unit circle? And remember how when with the unit circle we scaled it up? So if it has a radius of 3, it would be 3 times those coordinates. Do you remember when we did that a long time ago? Same thing. We can describe that point 2 different ways. We can describe it in terms of radius and angle, or we can describe it in x and y. Today, all I want you to be able to do is, if I give you a radius and angle, put a point on the graph. You've been doing that. You did that back when we did trig, right? You did it. But now this is a graphing technique. And then, if I give you a point, I need you to write down what the radius and angle is. You can read a graph. It's a different kind of graph. It's not x, y. It's a radius and an angle. So the whole point is this is in terms of radius, angle. So it's going to tell you on a graph, how far am I going to go up for my angle, and then how far am I going to go out for my radius. That's how we're going to get points now. And if you want, the words say the same thing I've been explaining. So let's try this one. Everybody, you're going to try B. What is my radius for B? Negative 2.5. So we need to talk about a negative radius. And what is the angle? Actually, let's do this together. It's negative. I got to show you what happens when they're negative. They did this in degrees. I'll tell you right now that I'm going to... Never mind. We'll do this right now, but when we get to the complicated equations, we're going to keep it in radians, okay? We're going to do degrees now a little bit, but we will quickly get to just radians. Okay, the negative radius. So the way you do these negative radius, you go the opposite direction. So what you should do first is the angle, and then go across. So for this one, you see how we did a radius that's positive? We were in the first quadrant. We had an angle in the first quadrant, and we went from the origin out towards that angle, right? A negative radius for this would have been this way. That's negative r. For that angle, this is the negative r. Do you see how it's going on the other side of the origin? But it's based on an angle. Positive is on the positive x. Negative is on the other side of the origin when we're doing rectangular coordinates, but when we're doing a radius, it's going to go the opposite direction. So first you do the angle. So this is a negative 120. So we're just looking at it just to get a sketch before we actually graph it. If it's a negative 120, what way are we going? We're not going counterclockwise. What way are we going? Clockwise. So we have to go 120 degrees, right? So is that 60 short of 180? So we're going to go around like this. This is a 60-degree angle. This is a 120-degree angle, right? Is that going to be the angle? Is that my theta? Okay, but I want a negative radius. So I'm not going to come out here. This would be r. Instead, I'm going to go this way. Same angle, right? So is this going to be a 60-degree angle? Do y'all see that because of vertical angles, that's 60 degrees? Okay, so this is a radius. This is the negative 2.5. Sorry, 2.5. Let me erase that. Negative 2.5. Do I have to come out this way? So now I want you to go over on that nice polar grid right here. And then you notice that this is going, and that means this is a 60-degree angle, right? Because this is 60 degrees. That's a 60-degree angle because this is 60 degrees to the negative 120. And we're going to go across. So this is the r, but I'm going to go to the negative r. Count out 2.5. Does that give you 1, 2.5? Yeah. So I went out 2.5. That's my negative r. This is my negative angle. Does anybody have any questions on that? When it's a negative r, you will go across. First you go the angle, and then you go across the origin. For a negative angle, you go clockwise instead of counterclockwise. That's as complicated as it gets. Oh, yeah, just takes practice. Just like everything else. Okay, let's try some. Right here. And this is all we're doing today. We're just trying this. All right. So start with the angle. Make it easy on yourself. Starting with the angle. Where's 60 degrees? Is it out here? Is that 60 degrees? I'm highlighting it. There's 60 degrees. Where is a radius of 3? So a radius of 3. 1, 2, 3. Is this whole circle a radius of 3? So it's 1, 2, 3. And where does this intersect? Right here. Is that the point with a radius of 3 and an angle of 60 degrees? Is that pretty easy? Thank you.
That was easy.
Oh, we gotta change the language. All right. So what about the next one? What's the angle? What's negative 4 pi over 3? So I'm going to go negative, right? So this is a pi over 3, and this is a pi over 3, right? And that's a pi over 3, and that's a pi over 3. There it is. Yeah? So I gotta come out. This is my angle. Is that where I'm going to end up if I do the angle? There, if I go all the way around, is that what I'm going to get? And then next, I need a radius of 4. So is it this circle right here? I'm not going to do a negative radius. I'm doing a positive radius, which means I'm not going to go on the other side. I'm going to actually find the point of intersection. Is that my point? Is that easy?
Yeah, good part easy.
Okay. Okay, now y'all try this one on your own. Ruh-roh. Give it a try. Come on, you can do it. Just try for me. $30, $60, $90, $120. I gotta go $150. Oh, look, right there. Is that my angle? But I don't want that angle, do I?
No.
I want the negative of it, right? So I'm gonna go the other direction. Okay. This, if I go around this way, that angle would be a positive. This would be a, sorry, that's negative. Let me write this down for you. This is a negative 150 degrees going this way.
How do you see that? I'll be like,
Because this is back from when we first started unit circle.
okay.
Going counterclockwise is positive, going counterclockwise is negative. So I got to go 30, 60, 90, 120, 150 to get the negative angle. Got it? So that's the negative 150. And then since it's a negative radius, if I was doing a radius, a positive radius, it would be on this arm right here. But since I'm going negative, do I have to go across the origin? And now I'm going to go find a radius of 2.5. There's 1, 2.5. Is that the radius I'm looking at? So is my point this point right there? Does everyone see how I did it? I did my angle, and then I went across because it's a negative radius, and I found the point at 2.5.
So whenever it's a negative, we find like the 210, we just do the opposite.
Yeah, you go across. It's not going to be on this arm out here. It's going to be across. Okay. So now I want y'all to try it.